Welcome to our competency-based question series designed specifically to enhance your conceptual learning and understanding. Question 2. An LCR series circuit is connected to an AC supply of angular frequency 100 radian per second. Given the values as resistance is 100 ohm, inductance is 500 millihenry, and capacitance is 5 microfarad. Study the following statements carefully and identify the correct option. So let's examine all the four statements one by one. Statement 1, it says the given circuit is dominantly capacitive. So to determine whether the circuit is dominantly capacitive or inductive, we have to find out the capacitive reactance and the inductive reactance. The capacitive reactance is 1 upon omega C, and that is equal to 1 upon 100 multiplied by 5 multiplied by 10 to the power minus 6. Because omega is 100 and C is 5 microfarad. So when we solve it out, it will be, these two zeros will cancel and we will be having 10 to the power 4 divided by 5. So that is equal to 0.2 multiplied by 10 to the power 4, that is 2000 ohm. So the value of capacitive reactance is 2000 ohm. And now we have to find XL as well, that is equal to omega L. Omega is 100 and L is 500 millihenry. So that is 500 multiplied by 10 to the power minus 3. So we can cancel 3 zeros with 10 to the power minus 3 and we are left with 50 ohm. So clearly we can see that XC is greater than XL at omega is equal to 100 radian per second. So when XC is greater than XL, the circuit is dominantly capacitive. So this statement is true. But remember, it is true for a given omega only. When the omega will change, the nature of the circuit may get changed. Let's examine statement 2. The instantaneous current in the circuit leads Vmax. Since the circuit is dominantly capacitive, we know that in a dominantly capacitive circuit, current will lead. So I will lead the given maximum voltage. So this statement is also true. Let's take statement 3. If omega is greater than 200 root 10 radian per second, the circuit becomes dominantly inductive. So in order to examine statement 3, we need to calculate the resonant frequency first. So resonant frequency omega naught, it is equal to 1 upon under root LC. The value of L was 500 millihenry, 500 multiplied by 10 to the power minus 3, and C was 5 microfarad. So we can write it as 1 upon under root 500 multiplied by 5 is 2500 multiplied by 10 to the power minus 9. It has to be minus 6 because it was microfarad. So it is 2500 multiplied by 10 to the power minus 9. Then it will become 1 upon under root 250 multiplied by 10 to the power minus 4. So 10 to the power minus 4 will go in the numerator, and in the denominator we are left with 5 root 10. So we can rationalize it, and we are left with 10 to the power 4 root 10 divided by 50. So 1 0 will cancel and it will be 200 root 10 radian per second. So the resonant frequency of the circuit has come out to be 200 under root 10 radian per second. Now we will examine the Statement 3, if omega is greater than 200 root 10 radian per second, the circuit becomes dominantly inductive. So this is the graph between the current and angular frequency. And we can see that this is the resonance frequency, 200 root 10 radian per second. So after the resonant frequency, if we move further towards the x-axis, the circuit becomes dominantly inductive. And before the resonant frequency, it is capacitive. So we can say that statement 3 is also correct, because after the resonant frequency, the circuit becomes dominantly inductive. Why so? Because XL will be greater than XC after the resonant frequency. Let's take statement 4. The LCR circuit can be made capacitive or inductive by simply changing the angular frequency of the input AC supply, keeping the voltage constant. So it is true indeed, because just now we have learned that after the resonant frequency, circuit becomes dominantly inductive, and before it, it is capacitive. And at resonant frequency, it is resistive only. So we can change the nature of the circuit by changing the angular frequency of the input AC supply, keeping the voltage constant. So this statement is also true. So we have examined this thing, that statement 1 is true, 2 is true, 3 is true, and 4 is true. So all the 4 statements are correct. So option D is the right answer. Thank you. Keep learning, keep practicing, keep excelling.